Translating functions. You will not need to take meticulous notes on the graphs. You don't have to draw every graph that I put up here. Just take notes on what happens when you change them a certain way. So here's what we're looking at first. The purpose of this lesson is not to teach you how to graph functions, because we've already done that many times. The purpose of the lesson is to show how they change when you add, subtract, multiply, divide certain things with them. These three functions are all going to be put on the same graph paper. We'll start with the first one. There's y equals x. Diagonal line. And it's looking like that because if I put a 1 in, I would get back a 1. 1, 1. If I put a 2 in, I get back a 2. Put a 3 in, get back a 3. So my points are all just like that. But if I changed that equation from y equals x to y equals x plus 5, then look what has happened. It's been moved this way. And that is from adding 5. You would think that if you added 5 to it, that it would push it to the right. It does not. It pushes it to the left. Remember, this 5 is the y-intercept, and it's crossing at 5 up there at the top, just off of it a little bit. Now look what happens when I subtract 6 from the original function, which is y equals x. If I subtract 6, I'm going to the right, and it's crossing at negative 6 down here, but that line looks like it is moved to the right from the original 1. That is the main thing you must learn from this first part. If you add a constant, then you're moving left. If you subtract a constant, then you're moving right. Graph each on the same plane. X squared plus 3, x squared minus 7. Now let's look at what happens when you do this. Remember what happened before with y equals x. When we added or subtracted something, we had to move left or right. Watch what happens here. Here is x squared. We've graphed this a bunch of times. But look what happens when I do this. When I add a 3 on the end of it, it doesn't move it left or right. It moves it up 3. It started down here at 0. When I add 3 to it here, it bumped it up 3. So if it's y equals x, and then we add or subtract some number from that, it moves it left or right. But if it's y equals x squared, and then plus or minus some number, then it moves it up or down. And here is y equals x squared minus 7. It moved it down from the original place there at the origin down to negative 7. Notice that it moves the way that it looks. If it's minus 7, it's going down 7. If it's plus 3, it's going up 3. It's not the opposite like the other one is. Okay, this is the absolute value function. Those are not 11s. That's not a 1x1 or whatever you want to think it is. It is the absolute value of x. The absolute value of x plus 3 and the absolute value of x minus 4. We're going to graph all of these on the same paper and see what happens. Here's the graph of the absolute value function, and here is why it is what it is. If I put a 1 in, the absolute value means whenever you dwindle the quantity inside those brackets down to one item, it will always come out to be positive. If I put a 1 in there for x, I get a 1 back. If I put a 2 in, I get a 2 back. 3, 4. That's why the graph goes that direction. But if I put a negative 1 in, I will get back a positive 1. That's what the absolute value does. Put in a negative 2, get back 2. Negative 3, get back a 3. That's why it's a V shape. Look what happens when you add 3 inside of that bracket. I've added 3 and it moves the vertices back over to here. Moves the vertex, I should say, back over 3 places. When I subtract 4, it's moved the original one from here 4 spaces to the right. What is the parent function? Is it the black function in this case, or it is the blue one? It is the black one, right. And that is y equals x squared. We've graphed that a number of times. How is the translated graph related to y equals x squared? So what has happened to go from here over to there? It's moved what? Yeah, they have subtracted 4, but let's try to figure out how they have subtracted 4. Up until this point, when we've had something like this, y equals x squared minus 4, didn't we move that down? Isn't that what we just went through? And if we added 4, if we did this and added 4, we would end up in this direction somewhere. Okay, so if it's moved to the right 4 spots and neither of these is what's happening to it, then how should the equation be expressed? Close. Kind of a version of multiplication. There will still be a y, there will still be an x, and there will still be a squared in it. But you have other items to put in there. It has been shifted 4 units to the right, and we'll come up with the equation now. So what is the equation for the blue graph? It is this. If you want to move a quadratic equation left or right, then you must put parentheses around the x and the number that you're adding or subtracting and square that quantity. This equation allows us to move this 4 units to the right. Minus 4 means 4 to the right. Remember that when it was just y equals x squared minus 4, you would end up moving it down 4 units. If it were plus 4, you would go up 4. If you want to go left or right, you must put it in this form. Okay, which one is the parent function, blue or black? Black, yeah, starts at the origin. Okay, and that is y equals the square root of x. We graphed that before. How does the blue line relate to y equals the square root of x? What has happened to it? It's gone up 5. It's shifted up 5 units from here up to here. What is the equation of the blue line? So here's what we know. We know that we have y equals the square root of x for this black one. But now what do I have to do to that in order to move it up 5? What do we do to move something up 5? Add 5. So we'll add 5 just like that. And that's it. Y equals the square root of x plus 5. What is the parent function in this case? The black one, right. And it's y equals the absolute value of x. So what has happened to this parent function here in order to get it down to here. How has it moved? It's gone down 3 and to the left 2. That's right. Shifted 3 down and 2 to the left. So now we have to find the equation for it. So let's shorten this up a little bit. And we will start here with y equals the absolute value of x. How far down do I have to move it? I have to go down 3. I have to go down 3. So I know I'm going to have a minus 3 in there somewhere. How do I move it left or right? Add or subtract, but I've already done that. Close. Starts with a B. The brackets, the absolute value brackets, right. If I want to move this 2 places back to the left, do I add 2 or subtract 2? You add 2, that's right. So let's put it all together. Y equals the absolute value of x plus 2 for your movement to the left, and then minus 3 for your movement down. So you have black, blue, and green in this one. Equation of the black graph. The equation of the green one is absolute value of x, close those brackets, and then minus 4. Yeah. F of x. What is f of x? Here's f of x here. It's the, I don't know, what is that? Red? Looks red. Red line. What is the equation for f of x? We've graphed this. Do you remember what it is? Not the square root.
X squared.
No, it's not x squared. Not the absolute value. That's a V shape. Think there's other stuff that we graphed yesterday. It was on the homework too. How about this is y equals the cube root of x? Does that work? Okay. What has happened to the cube root of x in order to get to this place right here? How has it moved?
Up one.
It has moved up 1. So what would the graph of that one be?
X or y equals x cubed plus 1.
Y equals x cubed plus, not x cubed, the cube root of x. Now is the plus 1 going to be under the square root sign or outside of it? It's not going to be inside of it. It's going to be outside. Outside makes it go up and down. Inside makes it go left and right. And then the other one, what has happened to this one? Here is the parent function here. I'm tracing it in black. Here is where it ends up there. What happened to it? It's moved 1, 2, 3, 4, 5 back. It's gone 5 back. If I want to go 5 to the left, do I add 5 or subtract 5?
Add 5.
You add 5. Remember what we're starting with here. It's y equals the cube root of x. I just told you on the last problem that if you want to make it go up and down, you put the addition or subtraction on the outside of it. If you want it to go left or right, you put it on the inside of it. Since it has to go back 5, it's got to be plus 5. So x plus 5, and it must be under the square root sign. This is a piecewise function. Piecewise means pieces of functions, such that some function made this here, and another function made this part with some kind of restriction on it. Like it could have been a negative x squared, with plus so many that made it go up. Whatever it was, it doesn't matter. You don't need to know what created this function in order to move it around. So just look at it as a whole. It's some kind of weird shape. And then where would these end up? What if I added 3 on the outside of that function, f of x? If I added 3 on the outside of it, not on the inside, up or down, so it would go up 3, right? So this one would end up 1, 2, 3. It would be up there. And then this one, if I subtract 4 on the inside, would it go up and down or left and right? It would go right because it's minus 4. So it would end up 1, 2, 3, 4 over there. Now keep these points in mind, this one and this one, and we'll take a look at and see if we got it right. There they are. It was moved up 3 to get this, and moved to the right 4 to get that. And we didn't even need to know how the functions were created. All we had to know was how to move them around the screen. We want to match these graphs here, this one, this one, this one, and this one, with these 4 functions. And once we do that, we want to match these 4 descriptions with those functions. Let's just start with matching a function to a graph. Let's go here and look at this. There it is. Remember, the parent function for this is y equals x squared. You have had 3 subtracted on the inside. If I subtract 3 on the inside, I'm moving where? 3 to the right. So we are looking for a U-shaped graph that has been moved 3 places to the right. We'll go in order. Is it this one? Does x squared open up or down? It opens up. This one opens down. This one opens up. Has it been moved 3 places to the right from the origin? Yes, it has. So that's the one. And we can insert E1 in here. That one's finished. Let's go to this one. We are looking for a U-shaped graph. Of course, they're all U-shaped on this one, in which it has been moved 2 places to what direction? 2 places to the left, and then 3 places in what direction? Down. Inside here, inside there is left or right. Remember, you're doing the opposite of what it says. It's plus 2 inside, then you have to do the opposite, which is going back in the negative direction. It's got to go left. Out here, outside of everything, it makes it go up or down. If it's minus, it is what it appears to be. It's going down. It's not like the left and right stuff. We need a function that has been moved 2 places to the left and then 3 down from our remaining choices. Is that it?
Yeah.
2 to the left and 3 down? Nope. 2 to the left and 3 down. Here's where it starts. This is the parent function. Has that been moved 2 places to the left and then 3 down? This is 2 places to the right. That's right, that's down. Look at this one. 2 places to the left, 3 down. That's the one. Alright, I think that one is E2. Alright, let's go back up here. What does this negative sign mean out in front?
That it's. Oh, I knew that.
What did it mean when we had this? What did it cause the graph to do? Open down, right. So that means we're looking for a graph that opens down that has been moved 3 places in what direction? Right. And 2 places in what direction? Down. Well, I think we only have one on there that opens down, and that's it. So that's pretty simple. And of course the last one is E4, and it should go here. All right, your descriptions. The graph of the parent function is translated 3 down and 2 to the left. Which one of these is translated 3 down and 2 to the left? That's right. It is this one. The graph of the function does not have an x-intercept. It does not cross the x-axis. Which one does not cross the x-axis?
E3.
Yeah, E3 here. That's right. And the coordinate of the y-intercept is 0, 1, and both x-intercepts are positive. Crosses at 0, 1, and both x-intercepts are positive. Is it this one? Are both x-intercepts positive on this one? No. Are they both positive on this? Does it cross at 0, 1? Yeah, so that's going to be it. And of course, by process of elimination, that would be the remaining one. The last one would be D4. You must graph the functions in the same coordinate plane. Do not use a graphing calculator. I'll give you graph paper to do this on. You'll need 1 sheet for this one. Write a function that translates the parent function of x squared down 7.5 units and right 2.5 units. And then for the third one, how would the graph of the absolute value of x be affected if the function were transformed to the absolute value of x plus 6, close the quantity, and then plus 10. You have to sketch the graph of the given functions below, starting with this one here. That's the parent function, remember? You don't have to know what created it. You just know how to move it. And for this one, study the graphs below. Identify the parent function and the transformations of that function depicted by the second graph. Then write the formula for the transformed function.